Okay, great. Grade 12, let's get started. So, as in the case of, there we are, as in the case of the vertical projectiles, when it comes to momentum and impulse, again, one of the most important things is the direction. You have to indicate the direction, and you have to use the direction in your substitution as well. Because remember, when we work with velocity, for example, it is a vector. So we have to consider the direction. It's very important. We cannot get away with ignoring the direction. So the direction is really important. If we just get, there we go. Okay, so remember in the previous exam, there was a very big issue with the use of the word closed system in paper 1, physics. So very important that we use the word isolated system. So they ask here, what is meant by an isolated system in physics? And the definition is in your guidelines. But basically, it is a system on which the resultant or the net external force is 0. So a system on which the resultant or net external force is 0. So just if some of you decide to only write resultant or net, remember it is a system on which the resultant external force is 0, or a system on which the net external force is 0. So it's not just a system on which the resultant force is 0, for example. You have to include all of those words. It's very important. During an experiment, a rocket of unknown mass is mounted on a toy cart of mass 20 kilograms. So the mass of the toy cart is 20 kilograms. So I'm just going to write that on here for myself. The mass of this cart is 20 kilograms. The car rocket combination moves at a constant speed of 2.5 meters per second along a horizontal floor. Now remember, we do not know the mass of the rocket. At a certain instant, the rocket is fired horizontally in the direction of motion at a speed of 30 meters per second. As a result, the cart slows down to a speed of 0.6 meters per second, as shown in the diagram below. Now remember, initially, this was one system, the rocket and the toy cart, and they were both moving at a speed of 2.5 meters per second. Okay. Afterwards, the rocket was moving at 30 meters per second, and the cart was moving at 0.6 meters per second. Remember, the mass of the cart is still 20 kilograms. The first question there is, use relevant physics principles to explain why the firing of the rocket will slow down the cart. Why will the firing of the rocket slow down the cart? So there's quite a few reasons that you can give, but remember, we have to use physics principles here. So the first thing you could say is that according to Newton's third law, the rocket will exert a force on the toy cart to the left or opposite direction of motion. That could be one of your reasons. You could perhaps also refer to the momentum. You could say that the total momentum is conserved, or the total momentum remains constant, but the momentum of the rocket increases. Therefore, the momentum of the cart must decrease. That is probably the reason I would go with. The total momentum is conserved. Why? Because this is an isolated system. So the total momentum is conserved or remains constant, and clearly the momentum of the rocket increases because the speed of the rocket is much faster. So the momentum of the rocket will increase, and therefore the momentum of the toy cart will decrease. So that could be one of your reasons. Anyone else have another reason that they want to try? Okay. Next up, calculate the mass of the rocket at the instant the rocket was fired from the toy cart. So we need to determine the mass of the rocket. What do we know? We know that the sum of the momentum before the rocket is fired will be equal to the sum of the momentum afterwards. Remember now, it's not, I'm not referring to the change in, I'm referring to the sum of the momentum. Also, I have the speed at which the rocket is traveling with the cart before the time, but I also have the speed of both the cart and the rocket after the rocket has been fired. So when I do my calculation, first things first, I am going to choose a direction as positive, and I'm going to choose to the right as positive. Now, because the velocity or the speed before the time is to the right, this is going to be positive 2,5. After the rocket has been fired, they are still both moving to the right. So this is also going to be a positive 0,6 and a positive 30 meters per second. So in this case, we are very lucky because the direction remains the same. Now, sigma, which means the sum of the momentum before the rocket is fired, is equal to the sum of the momentum after the rocket has been fired. The mass of object 1 times the velocity of object 1, let's say this is the cart, plus the mass of the rocket and the velocity of the rocket. This is before the rocket has been fired. Will be equal to m1 v1 is plus m2 v2. But now this is going to be initial, and the second part is final. Okay. Now I substitute. So the mass of the cart is 20 kilograms, and it is traveling at 2,5 meters per second. I don't know the mass of the rocket. I want to determine the mass of the rocket times 2,5. You could have simplified this as well. You could have gone with, because now remember the velocity for both of them is the same. So it would be the mass of the cart plus the mass of the rocket times 2,5. You could do that as well if you wanted to. I'm not. I'm going to stick with keeping them separately. But there's nothing wrong with doing that. So 20 times 2,5 plus the mass of the rocket times its velocity of 2,5 is equal to, again, what is the mass of the cart? It's 20 kilograms, and it is now moving at 0,6 meters per second, plus m2, which is the mass of the rocket, times 30. It's now moving at 30 meters per second. And now it becomes quite simple, because all I have to do is I need to solve m2. So what is the mass of the rocket? I'm waiting there in the chat box. Do the math so long. I don't have a calculator, so I can't do the math for you. Sorry. Okay, I do have a calculator, but it's not my usual calculator. Let's see what answer you get. Yes, if you get, therefore, M2 is equal to 1,38 kilograms. That is correct. Is this my final answer? I hope not, because the question is, calculate the mass of the rocket. So I'm going to conclude by saying, therefore, the mass of the rocket is 1,38 kilograms. Okay, grade 12. So what's the moral of the story when it comes to when it comes to momentum and impulse, very important. You need to keep the direction in your substitutions. Okay, consider the direction. You cannot ignore the direction. Very important. Grade 12, any questions about the momentum? Happy? Okay, great. I'm going to stop that video then. That it's a nice short momentum video.